Hi everyone, a very good morning to all. Now we are going to study about the question number 93. Applications of diode, or what is PN junction diode, you can say simply. See, the very first thing is, what is PN junction diode? When you consider P-type, we add trivalent atoms, so they are ready to accept the electron, so that they behave like negative ions inside the material. So that every impurity atom give or create one hole. So that there are so many holes. The whole number we will increase by adding trivalent. Also there are some little number of electrons. Now when you consider N-type, we will add pentavalent atom and they donate one electron and they become positive ions. They behave like positive ions. So that we add like more number of electrons. So electron number we will increase and a small number holes also will be there. Now when you kept them in contact, so this is called PN junction. PN junction diode. Now what happens is at the junction P-type P-side holes and N-side electrons will recombine up to some region. So that one side negative ions will be there, another side positive ions will be there. So that there is some electric field will be developed, barrier field. There is some potential difference will be there, barrier potential, and that resists the charges to cross across the junction, so that here no conduction will happen, and that is called depletion region, and that potential is called barrier potential. Now how does we make it to work is, we can connect diode in two different modes. First one is, when you consider the PN junction diode, you connect in such a way that P-type to positive terminal, N-type to negative terminal, or you can connect in reverse. So this is called forward bias, and this is called reverse bias. So you can connect in both the ways. And what happens here is, when you connect them in forward bias, the voltage of the battery should be greater or equal to VB, then only it will conduct. And one electron will be added from here like this, and one electron will be removed from here like this, so that the electricity flow will happen when this condition is satisfied. And that kind of connection we call it as forward bias. But here, when you consider P to N, so electrons are flowing from N to P, so the current will flow from P to N. So forward current will flow from P type to N type. That is what we have to understand. And one more thing is here, when you consider forward bias, here P type means more holes will be there. So they get repulsion from the positive terminal. N-type means more electrons will be there. They get repulsion from the negative terminal. So majority charge carriers are crossing the junction. So they are trying to diffuse each other. That's why we call it as diffusion current. And the current is due to majority charge carrier. That's why huge current will come. But in case of reverse bias, when you consider here, holes will be there, also small number electrons will be there. As it is connected to negative terminal, electrons will get repulsion. And here more electrons will be there and less holes will be there. And here it is connected to positive terminal, so holes will get repulsion. So that here minority charge carriers are crossing the junction. So the current, reverse current is approximately 0 up to some range. And at very high voltage, called breakdown voltage, reverse current increases to maximum suddenly, increases abruptly. Very sudden increase, gradual increase in the reverse current. Because at very high voltage, what happens is within the depletion region, the whole electron recombination happened that got broke, and suddenly large number of charge comes into action so that the current increases to very high value. That is called reverse bias. And what is Zener diode? There are a lot of diodes, different diodes will be there. And they used to ask question based on Zener diode mostly. Zener diode means it is the one diode. See, normal diode means we will represent this. This side is P, this side is N. And when you consider Zener diode, we will represent like this. And it works in reverse bias. And it is a device which maintains constant voltage across an electrical device, like voltage stabilizer. It acts like a voltage stabilizer. Now, based on this thing, how the questions will be asked, let's see. Now, the very first thing is, here, always they used to give resistor and diode combinations, or sometimes capacitor and diode combinations. And whenever they give like that, if the diode is in forward bias, then you can consider that in the circuit because it allows current flow. Otherwise, you can remove that part from the circuit. Like find the net resistance of the network shown in the figure between the points P and Q if Vp greater than Vq. If Vp greater than Vq, then current will flow from here and it will divide. Then diode will be in forward bias. Therefore, the two resistors will become parallel. So the R effective will become parallel, means 12 into 4 by 12 plus 4, 16. 4 4s are 4 3s are. Now, if VQ greater than VP, then diode will be in reverse bias. So as it is in reverse bias, because now the current will come like this. Now the current will flow from like this and it will divide like this. Now this is reverse bias. So that the circuit will become equivalent to like this simply. This is P, this is Q, and the effective resistance is only 12 ohm because no current flows through 4 ohm. Like that, you have to understand and you have to solve the questions. Now here, similar one more question is there. A diode used in the circuit shown in the figure has a constant voltage drop of 0.5 volt. Means it requires 0.5 volt to conduct at all currents and a maximum power rating of 200 milliwatt. What should be the value of the resistor R connected in series with the diode for obtaining maximum current? So here, the voltage across the diode is 0.5 volt and the power is 200 milliwatt. So power equal to V square by R. So that the resistance will become, V square by R or V into I or I square R. So here they did not mention anything like diode is having some resistance. So here, when you consider P equal to V into I, the current in the diode will become I equal to P by V, where P is 200 into 10 power minus 3 by voltage is 0.5. Then you will get the current in the circuit. Then now total voltage applied is 2 volt. Now voltage across resistor will become 2 minus 0.5, that is 1.5 volt. Voltage across a resistor is I into R, but both are in series means current must be same. Then resistance will become 1.5 by I. So I value you will get it from here, like point if it goes 0, so 400 into 10 power minus 3 or else 0.4. So just take the I value and substitute here. Then you will get the unknown resistance value capital R. So here the thing is some voltage drop is there across the diode. So you will get the remaining voltage across the resistor, first point. And they have given power and voltage across the diode so that you can find the current in the diode. And same current will flow through resistor, just like series and parallel combination only. Now find currents passing through 4 ohm and 8 ohm resistances in the circuit. See here, the current will start from here so that it will divide into two parts, I1 and I2. But as D2 is reverse bias, then I1 is approximately 0, so that no current flows through 8 ohm. And D1 is in forward bias, so that now the circuit will be replaced as simply like this. So the effective resistance across the combination is R effective will become only 4 ohm. Now the current will become V by R. V applied is 12 volt. 12 by 4 equal to 3 ampere. So across 8 ohm 0 current, across 4 ohm 3 ampere. That way you have to understand. Now the next question is about Zener diodes here. How to deal with it. Now some voltage 20 volt we applied. Here 250 ohm. Here Zener diode. Here 1 kilo ohm. Now find the current through the diode. Now see here, the Zener diode has breakdown voltage 12 volt. Means it should conduct means here 12 volt must be there. Otherwise no current in the circuit only. So that it will not work as a Zener diode. So it is working as Zener diode means 12 volt will go here. That means across 1 kilo ohm also 12 volt must be there because both are connected in parallel. That is the first thing you should realize. You have to take the Zener breakdown voltage and you have to apply the same voltage across the resistor, across the load resistor which is connected in parallel. So that here you will get the current. Let's take suppose total current I. Now here is I1. Here it will become I2. I2 means this is IZ actually. Now here I1 is coming. Here I1 will become how much? 12 volt we applied by 1 kilovolt. That means 10 power 3 ohm, 1 kilo ohm. So that 12 milliampere will come. So this much of current is coming here. Now here 12 volt is gone means the remaining 8 volt will appear here. So 8 volt is appearing here means the total current I equal to 8 by 250. Like 2 4s and 2 125. Now 4 by 125. Now to calculate it, just take like it, like 1000 into 10 power minus 3 I have taken. 125. 25 5s are 25 4s are 0. 5 8s are. Now it will become 32 milliampere total current is. Now here I equal to I1 plus I2. So that I2 will become I minus I1. That is 32 minus 12. So how much it will become? 20 milliampere. So this is the current through the Zener diode. So this way you need to solve the questions. Now one last and final question. See here a reverse bias diode. So in here which one is reverse biased? See minus 6 minus 3. Here minus 3 this is 0 volt and this is 0 volt and this is minus 2 volt. This is 2 volt, this is minus 3 volt. So here I potential this one, so the current will flow from here to here. So forward bias. Here 0 minus 2, this is also same thing, forward bias. Now here minus 3 is 0. So the current will flow from high potential to low potential, reverse bias. And here minus 6 minus 3, minus 3 is greater. Now this is also reverse bias. So that means first two are connected in reverse bias, second two, remaining two are connected in forward bias. So that way you need to understand. Means like which diode is reverse biased means the current should flow from high potential to low potential such that if the current is flowing from N to P, reverse bias. If the current is flowing from P to N, then it is forward bias. So this is how they will ask questions based on a junction diode. So just try to understand, and similar questions I have given as an assignment. So just try to practice them so that you will understand the concept. And sometimes they will give this kind of, see, as you are showing, as you are seeing, the theoretical based questions also they can ask based on the depletion region, barrier potential and all. And see here NCRT questions also there, few questions, try to solve them. So thank you all. We'll continue in the coming session with the another question.